So I hope you enjoyed your coffee, you're re-stimulated, re-energized, and we're going to continue with our presentation. And one of the things we left you with tier storage was that third tier, that backup and archive. And this is obviously a critical element that we need to really think about. And one of the concerns we have at the moment is backup and this ill-perceived concept that if our storage is raided, it's backed up. And that just really isn't the case. What we're really talking about is if we're raided, is we can keep the disk drives going if one fails. So what does that mean? Why do we have to worry about that? So I want to start with a standard diagram we pulled off from the manufacturer's website. So this is our mean time between failure for a disk drive. And as you can see from that disk drive, this is the traditional bathtub curve. Hopefully most of us have heard of that. But what it says, we have a high failure rate right at the very beginning. Well, that's pretty much ironed out by manufacturing. Those drives literally are shipped to us after they have that curve ironed out with that process. And then we've got 5 to 7 years where we really don't expect to have a problem with the drive. So there's no issue with disk drives at all. And then we're going to start seeing those drives wear out and actually start failing on their systems. So why are they concerned about disk drives as our backup? If they've got a reliable 5-year life, why are we worried about that? Well, it's really because of the way we handle our drives. And when we talk about centralized storage, we're actually talking about handling multiple drives striped together as one system. So very typically, my centralized online storage, where I need high bandwidth, I need collaborative workflows, I'm probably going to start looking at 24, 48, 64 sort of set of drives all raided together as one system. So when I raid together 24 drives, I have to take this curve and divide it by 24. My expectation for failure now is now being reduced from 5 years to every 2.5 months. Okay, so I'm expecting the drive to fail every 2.5 months. That's not unrealistic. So what happens with RAID? What RAID enables me to do is that when a drive fails, I have the ability to replace that drive, rebuild the RAID, and carry on working. The problem I have is whilst I'm going through that process, I've got no protection. So if I lose 2 drives, guess what happens? I lose all my data. It's gone. It really is as simple as that. And this is why we have to be very careful about how we approach that. So obviously there are ways we can improve on that standard, and we talked earlier on about our nearline storage, and then we actually start introducing enterprise scale redundancy in the system. So that means we're not only using RAID, we're doing multiple mirrored, we're distributing our data across different servers, different disk drive sets, etc., to try and minimize that risk, to increase that percentage so we can actually reduce that risk of the system. But clearly, high expensive storage in an enterprise scale redundancy system is going to be incredibly expensive. You're fundamentally reproducing and replicating that storage media across all of those devices. And that's the only way we can secure that disk drive technology can be reliable. And in reality, in post-production, we can't afford to do that. There's a critical area, we just can't afford to do that. Remember, cost, performance, and risk are all directly related to each other. So what do? We've got to think of an alternative. We need an alternative. And then this is really where we come into tape. And this is probably why we avoid the phrase tapeless workflow today, because actually tape is playing a very important role to us, and why we tend to stick about file-based workflow. And when we talk about tape, we really are introducing LTO. We see LTO as a critical element to our tier 3 storage and our archive future. So LTO was conceived in 2000. Interestingly, it really comes about from technologies that were developed in the 1990s. And it becomes quite interesting about the process of how long this technology has been around. But in the 1990s, we had a tape-based archive mechanism called DLT, and Sony had their Exabyte. And then you've heard of those things. And they were very proprietary tape-based systems from those manufacturers. And really what happened is like HP, IBM, etc. got together and says, look, we need an open standard that we can actually present to the marketplace that everyone can actually interface into. And LTO was born. So LTO was born, fundamentally the Ultrium standard on the system. And we went through our various versions of LTO. So LTO 1, when you can see there, the original tape, 100 gigabytes of material. And if you look at LTO 6, newly launched last year, we're actually starting putting our first implementations of LTO 6. We're now up to 2.5 terabytes of media in the same form factor, a little LTO square tape. So it's a highly dense format that has a 30 to 50 years shelf life. So we can record on the tape and put it on the shelf, and in 30 or 50 years' time, we can play it back. Or can we? We have to face another reality here. And that although that tape shelf life is 30 to 50 years, the ability to have that deck still working that can play back that format in 30 or 50 years is very unlikely. And this is where we have to allow for data migration and format migration. So traditionally in our broadcast world, where we're working with videotape and we had all our masters on 1-inch formats, what did we have to do? We had to change formats as that technology is moving forward. So we'd go through a very expensive re-archiving process from our 1-inch, probably to our D3, hopefully a digital format. Maybe it went to Beta SP. We may have gone to DigiBeta. Now we've got to seriously think about going to SR, etc. You can imagine the cost of maintaining your library, although we had to keep up with technology migration, was very, very expensive. One of the beauties with LTOs is that we can migrate, because we keep the format of the data the same. We're not doing a format conversion. We're just migrating data from one tape system to another tape system. And we can actually automate that entire process. So one of the really nice things is that longevity of the LTO, and we can see here when we start talking about data migration, what was really good with LTO1 in 2000, obviously you can read and write LTO1, but really it's that backward compatibility pattern that we see. So typically all systems are read and write capable one generation in behind, and also they're able to read 2 generations behind. So you can see here, if I look at my, let's just say I want to migrate my LTO3, I've got an LTO3 library, and you can see with my LTO3, I can take that to LTO5 today because it's able to read those tapes. So we need to think about data migration, etc. on those systems. So obviously that's the physical mechanism of the tape itself, that 30-year life, the ability to easily migrate it forward. The fact it has that compatibility with previous generations is very, very useful to us. It means we can actually now start managing our libraries much more efficiently as technology moves on. One of the elements we do need to think about is actually the filing format or the formatting format of that tape. And I think in this area, typically we've had very much proprietary formats. So we saw people like XenData with their TAR formats. We've seen people like FrontForge with its AXF format, which are very, very proprietary. And the problem with it being proprietary is that if I want to take that tape archive and go somewhere else with it, I can't do that. I have to republish that into another format to allow it to actually fit. Or I have to make sure I've got FrontForge at both ends or Xen at both ends. And that's a real problem. And we were talking earlier on about tangible and non-tangible assets. But the idea is we want a tangible asset that we can take and we can play back anywhere we want to go to. And that's become very, very interesting recently with the advent of LTFS. LTFS is our linear tape filing system, but it's an open forum. So I can take an LTFS tape that's produced on my Xen, and I can go across to my cache and play it straight back and get all my data back. So suddenly I've got that tangible asset that I can now move around without having to invest in the specific software that actually wrote that asset anymore. So we're very excited about LTFS, and we're going to talk about that later on. But what we do have to think about with LTFS is there are actually a lot of issues about how we handle and manage LTFS. And those issues really come about how LTFS is presented. It fundamentally has created a disk, a DOS sort of based look at a tape. So if you imagine a disk drive, and obviously you can mount your USB drive and your filing systems there, and because of the random seek and read capability of disk drive, you can jump around that disk and read media off. Apply that concept now to a linear tape that has no random access. So there's some issues the way I have to deal with it. First, my biggest issue is I must stream that single file off in one contiguous block. If you think of multiple people accessing the LTFS tape today and creating fragmentation. Now I think we've heard of fragmentation on a disk drive basis, and it takes a long time before we have to defrag the drive. Now think of that linear single sequence tape getting fragmented. Well, it's just a horror story. So we need software that can manage that. Doesn't mean it's impossible. We need software that can manage that process. And typically we're dealing with cache servers that actually pump the data down in sequential order and actually make that work for us. The other problem we've had with LTFS up to now is that obviously it's a single volume, it's a single tape cartridge. And really, if we want to be efficient with our tape libraries and our big systems, we need to start spanning tape. And it's quite interesting now that we're seeing now that we have this industry standard that everyone can adhere to, and actually we're seeing a lot of the archive manufacturers are now looking to develop spanning technology and take advantage of the LTFS format, which means it's going to be much more portable. So what we're going to do now, I'm actually going to hand you over to Dave again, who's actually going to take you through that promotion, demotion perspective, but actually take you all the way down to the Tier 3 archive process and actually deliver and restore media onto an LTO tape. So I'll pass you to Dave.
So just before we get to the promotion and demotion, what I will show you is just the XenData sort of back end, which is our tape archive system. So what we've got here is the XenData management console. You'll notice at the very bottom here, we've got a single standalone drive, which is just on top of the workstations. Typically, if you had a library system, all your drives, your mechanisms would be listed at the bottom, and you would have your library. And the XenData takes care of, mounting the tape from the slots that are in the library, moving it into the drive as and when it's required with a barcode reader. So it's the robotic arm inside a library. Here we've only got the one drive, but we can, show you exactly how it would work. So XenData is basically a file system, and it's a filter system starting from the top, which is our file configuration groups, and ending at the bottom, which is our actual LTO tape. So for instance, if we have a look at our Pinewood configuration group, we're saying here anything within the Pinewood folder within the XenData environment is going to get saved to tape. We've got that selected top right. But the key thing here is the volume set. So within XenData, you have this term as a volume set. Now that's actually a group of tapes. So if we were to say we only want to write to this tape and this barcode number, once that tape's full, you'd have to manually intervene and say, right, I want to write to this tape. So what XenData do is they have this term as a volume set. And what it does, within the library, you'd have your blank tapes at the bottom here. So if you had your multi-slot library, you'd have 10, 20 tapes that are just blank media. And what will happen is, as and when the tape gets full, and we set this up here in your configuration, so we've got set at the bottom here, when your volume reaches 95% full, grab a new tape basically from the blank media. So as long as there's blank tapes within your library, it'll be self-loading as you go through. You'll also notice at the top here, we can set the file system up. So there's XenData tar, and now you've got LTFS. So you can then start, doing your changeability between other systems. So also what we can do within the volume set, we can actually replicate. So if we just take the Chiswick volume, for example, and we go to replication, what we can do here is we can say, right, instead of writing to one single LTO tape, I want to write to a second tape. You can either do this immediately, and what you need for that is you need a second LTO drive in your library, because you'd write two streams onto two separate tapes concurrently. Or if you only had the one drive or limited drives, you could say, right, I want to replicate at midnight every night. And what that will end up doing is you'll have two LTO tapes with the same media spread across, the two tapes. So that could be your disaster and recovery on a Friday. It could be taken off to a second facility or home or the likes of that. As the volume sets fill up, you'll have a list of your tapes here, and that's all your media. So what we can say here is everything that comes in within the Pinewood area within XenData is going to get written to the Pinewood volume set. And we can categorically say that all our media from Pinewood is going to be written to this specific tape. And then from there, you can generate a report. So there's a report generator. So if we just have a look at the barcode number, it ends in 290. We can go to tape contents and 290. And what that'll do is that just generates a very basic report of what's actually on that tape. So that can be stored within your asset management, or you can, print out a report and put that on with the tape on the shelf. So what I'm going to show you here is a very basic archive operation. So at the very bottom here, we have like a system log. It tells you exactly what's going on. And I've created a Windows share for the Pinewood volume set. So this could be your raw camera rushes as they come back in from the shoot. You need to back them up onto LTO because you've only got them on one FireWire drive. So you can just drag and drop straight away into there. It's a network copy. And then you can see at the bottom here, 1238, we've got a write. So that's writing that file straight to the LTO tape. So you can see how sort of simple the XenData implementation is. So that sort of XenData is a very sort of standalone operation. What I'd like to show you now is how we can automate that a little bit further with Object Matrix. So then we'll be moving our stuff from tier 2 storage to our tier 3 tape. So we've got another monitor tool, the LTO monitor tool, which I'll just open up here. And then we're just going to go back into Dropspot, which is looking back into the Object Matrix storage. And then I've selected the interplay archive. And then if we remember earlier, there was a clip. It was shot number 13. So that's now been pushed from our interplay, which was on our tier 1 storage. It was automated to our object matrix. And now if we wanted to push that to our LTO, we can simply go in here and we can right click and say archive to LTO. So now we've got that job submitted, and we should see, in the background, and then you can see the XenData right in that media. So we've just pushed our media from our tier 2 storage straight to LTO tape. And we could go one step further, and you could automate the whole process from Media Composer so that your media would be archived or migrated to your tier 2 object matrix and your tier 3. And then as an administrator, you could go back and then you could remove it from each volume. And then the great thing about this is that it leaves the link all the way back to Media Composer. So as soon as someone needs to restore that asset, you can just pull that all the way back from LTO tape. So hopefully that shows you how we can automate the promotion and demotion from tier 1 down to tier 3.
Cool. Thank you, Dave. So I think we obviously talked about cost analysis or whatever, and clearly when we talk about cost, when we finally get it down to that tape and put it on our shelves, air conditioners removed, we just got that storage space and the cost of that media. We're into our most minimum long-term cost basis that we can actually survive in. So it's been very good for us. So we've reached a very important juncture. We brought all our media in. We obviously live editing. We brought our files into our systems. We're tracking those through our asset management systems. We manage our storage so the media is actually sitting in the right storage element, whether it's online, whether it's nearline, or whether it's archive. We've talked about the archive process, and suddenly the idea that we can have that tangible asset where you can say, my production is on that tape, and we can give that to our clients, and we may give them disaster recovery, say, we'll manage a copy for you, and we'll give you a copy. And we've talked about LTFS, that the ability that they can take that clip and play that back anywhere and actually put that media back onto their storage or someone else's storage. I think it's going to be a really important business model and security model for the production community to be able to say, okay, I want you to manage my archive, but I want the reassurance that I actually still own and hold my rights, my media rights. And I think that's going to be a very interesting process that we're going to do. We're actually starting to put a business model together very shortly for a duplication house in town who are very much working on that idea. And they're actually going to be presenting that business model to the production community. So we've reached this point. All our media is here now ready, and we can now start manipulating and editing it in our post-production environment. And we're not going to do a demo of Media Composer or Final Cut or Adobe today. We feel that those have been demoed strongly enough in many other scenarios. But we really need to talk about how do we move this media around our different applications. And clearly, one of our common ones is going to our audio suite, our Pro Tools. We're very used to that. We actually deliver a compositions layer, or we deliver a QuickTime move with the video, and we're linked to the audio. So we're very much used to that file-based movement of media between other devices. But clearly there are more applications necessary in this scenario. And I think one of the leaders, very early about interactive software that worked in different environments was very much Adobe with the Creative Suite. We just saw some amazing integration about the way the After Effects integrates back to the Premiere timeline, about how we can go in and modify things with After Effects and watch them live update in Premiere, and how that metadata and everything would interchange. But it was very much a standalone work group environment. It didn't have that collaborative shareability, and that's something we're going to be very much interested in watching how Adobe move forward with that. With Final Cut, there were two elements about how they interchange with other software applications. One of the key things is that they were QuickTime native. So if the file was QuickTime, we could literally drag that file between any device. Because of their lower layer of media management, and actually the media management was done on the filing system of the computer, we actually had the original name of the file always present. We didn't have to worry about database infrastructures and AAFs and unique identification. So it's very easy. There are obviously some weaknesses to that. It was very easy to move data around. Equally, their timeline was built through an XML describer, and that meant we could interface with that timeline and move data around other things. So one of the big products at the time we used to sell quite a lot of, or less of nowadays, was a product called Automatic Duck. So it did translation services between Final Cut and Avid and Adobe, and allowed us to move material around. With an element of success and lack of success, there always was quite a bit of manual processes involved. So at the same time, we also have Avid AVX, and AVX has grown up from AVX 1 and 2, etc. And has really come to demonstrate some really great integration facilities at the moment. We're actually going to give you a demo of a product called Eyeon Fusion. And the reason why we've chosen to do that is that there's a quite strong element. With the Avid's move to Media Composer 6.5, they've been unable to take the existing bundles of software, Boris, GenArts, etc., forward into 6.5. So it's a unique perspective that you have to think about. I have to reinvest in my plugin architecture. And what we're saying to people is that, okay, this is an opportunity to evaluate and actually rethink what plugin architecture you want in your system. So don't just say, I'll go out and buy Boris and I'll go out and buy things. Look at what you need and see what's available and see if that's the best choice you're going to. And one of the new options come out is Eyeon, which is this, very high-level brand-leading compositing solution that's actually developed a software called Connections, which integrates that complete composite environment directly into the Avid timeline. So I'm going to hand you back to David, who's actually going to give you a quick demo of that integration. So here you go, David.
So we're back in Media Composer with our sequence that we've finally edited together. So I'm going to add an effect to this area of the sequence. So if I dive up into my effect palette, we can see there's an Eyeon connection effect. I can drop that onto the first clip. And the first thing you'll see is it says how many tracks do we want to apply this effect to. So if we had multiple video layers, you could say I want to apply the same effect to the 4 video layers. We've only got the 1, so the 1 will do. As ever, you open up your effects editor within Media Composer. And the first thing I need to do is export the clips from Media Composer to Fusion. And what we're doing, we're actually moving and creating raw files which are uncompressed. So within Fusion, you can do frame accurate compositing, so you don't have to sort of guess where things are and things like that. Second thing is I just want to open up Fusion. So down the bottom here now, we've got our Fusion software. It's node-based compositing, so I don't know if anyone's had any experience with multiple layers within, say, After Effects or Media Composer, and you start moving the layer down the bottom, it all becomes unrendered and all out of, out of alignment. So with node-based compositing, you can join up your nodes as and when you go, and you kind of remove that complexity. So the one on the left is our loader, which is our sort of our source, and then is the save on the right-hand side is what we're going to create. So simply in between the two here, I'm just going to add a color correction, which is this node here. I'm going to do some subtle blue color effect to it. And then I'm going to render that within Fusion. Now, if I dive straight back into Media Composer and start playing back our sequence, you'll notice that the first couple of frames have already been rendered. So as it's rendering in the background, it's updating our timeline as we go. So you can see that there's a good sort of round trip going on here. Once the render's done within here, it'll be fully real-time playback within Media Composer. So as you can see, it's growing as it goes. So with that render done, I can select OK, and then if that was the final piece, we could be happy. But more often than not, the director or producer may not be happy and say, right, can we have another look at that? So within Fusion and Media Composer, they have something called versions. So I can create a new version here. So on version 2, it takes us back to our neutral timeline, and then I can go back into Fusion and I can do a subtle red color grade to it and render that as before. Dive back into Media Composer and you can see that straight away it's gone red. And I do believe out there's some indecisive directors, and they may turn around and say, actually I was happy with the very first version, and you can just literally slide the slider back and you've got version 1. So if you spent, a day compositing that and it's a waste of time, you haven't lost, your previous work. So hopefully that shows you how easy it is to round trip between Media Composer and Fusion. So sticking with Fusion now, I'd just like to show you some other things that it can do. I mean, typically within Media Composer, there's a lot of sort of rostrum moves. So if I load this one up here and if I zoom out slightly, so this here, we've got it's sort of what they call pan and scan within Media Composer, but this is a rostrum. So we've got our frame size in the middle, which is 1920 by 1080, and then we've got a much larger image on the outside. So if I just switch into spline view, you can actually see we can have very, finite control between all our sort of keyframes. So one of the limitations with Media Composer and Symphony is the keyframe capability. You can't really get some nice smooth, transitions and sort of beziers as they call them here. So from here, we can play that sequence and we can actually see what's going to happen in our final result within Media Composer. And you can see some nice smooth transitions of movement and, rotation. So it can be used, for rostrum, and then of course that will update your timeline back straight into Media Composer. One other thing that I'd like to show you is on that one. It would be sort of color blur. So within Media Composer, I think traditionally it's done, police camera action or something like that, where you've got to blur out all the number plates and track them. It can be quite laborious, having done it myself. With here, you get a lot more control with what you're doing. So again, as we had before, we've got our loader at the beginning. And what we're going to do here is we're going to blur out Damon Hill's VW badge on his chest. So he's in an interview and he's moving around. So the first thing that we need to do is load a tracker onto the badge. And then once we've done that, we create a poly and draw around that, which has been tied to the tracker. And then from that, we add the blur. So you can see the blur that's been added. And then that's going to track it. So if we play the whole sequence through, which I think it will render as well, you can actually see that it's starting to do the blurring and as they move around. So you can have multiple, blurs going on within the same effect. So there's a lot of capability, much beyond my experience. And with that in mind, I'd like to just leave you with something that has been created on Fusion before. So our source file here is, if I just select play, is a still image of a picturesque town somewhere. And our final image is actually a sort of a moody, dark 3D sequence with rain and, there's a 3D effect going on. And that's done by creating, depth maps within here and then adding on the individual elements of rain, mist, and the light glare from the windows. So you can see there's a very powerful tool to do a lot of stuff, and you can get that straight back into Media Composer with, relative ease.
Brilliant. Thanks very much, Dave. As I said, we want to introduce that because I think it really is a time to reevaluate your plugin architectures, especially in the Avid environment. Immediately you look at that and see that this is an incredibly advanced compositor, and we're finding that those basic functions, we chose the tracking and the blurring, because obviously that's a really important feature for a lot of programs, and we need to be able to do it very, very fast. And typically, the fastest way we can do that is actually using Media Composer tracking and Media Composer blurring to do that. But obviously, with the advanced tracking tools that we have in the Fusion, the much more advanced rendering processes and that integration timeline, we're finding that's actually a much quicker way to actually handle those processes. So obviously, you immediately think, well, it's an advanced composite, it's got these amazing advanced tools. I mean, how much is it? £20,000, £30,000. I think it's roughly the same price as Forest. About £1,000, something like £1,000, maybe £1,200. Maybe someone with sales will advise you later on if you mind more details, but it's definitely worth having a look at. I would recommend it. So we're finished. We've created a program. We've tracked it, we've managed it, etc. And we've now got to think about delivering it. And this is obviously a very hot topic at this moment in time, because one of the great things, traditionally, the way we deliver it is we play it back to our tape, our DigiBT, our SR, our HD cam, whichever format we chose to do. But we play back a tape and we'd ship it by courier or whichever route we found to do. And we obviously feel that there's actually a lot more efficiencies if we can deliver on file-based systems. So what's been really great is that the consortium of broadcasters from Sky, BBC, Channel 4, ITV have got together under the Digital Production Partnership. And they have conceived a structure of a file standard that they will accept as a delivery format. So for the first time, we've actually got a standard that we can work to about how we deliver files to this. So let's just try and understand that. And this is going to be a brief overview of the standard. So that they've chosen the standard and they've worked with one of the industry partners, AMRA, to utilize their AS11 standard. So this is a form factor for MXF OP1A. One of the key things is what they've got is a DPP shim. And this shim enables us to insert metadata into this file that is not technical metadata, but production metadata. Now obviously the reason why they want that is equally the broadcaster wants automation. They want to be able to automatically pick up that file, understand what it's about, and actually know where it's going to be delivered to or what they've got to do with that file internally. They don't want to have people sat on the server manually cutting and pasting and dragging and dropping files. So they want that automation. So we really appreciate that we need to have that metadata in that element. So obviously the key is this, as I mentioned, an OP1A file. So we've obviously got our layers of our video and our audio, and we've obviously got our layer of metadata. If we go through that structure of that file again, they've chosen AVC intro. 100 megabits has the high definition codec. So we need to be able to create that AVC 100. if we're delivering a standard def program, then it's the IMX50. That's the 50i MPEG-2 format. It's 422 color space. It's fundamentally a H.264 file format, is what ABC Intro 100 is. And obviously it's fixed frame size. So again, that sounds, well, of course it's fixed frame size. Why would it be different? It's another one of those details that you'll see manufacturers say, I make ABC Intro. You need to test it first. You may find, A, it doesn't play back in another device because there are various headers that need to be filled in on the ABC Intro. And the other issue we've run across is that the first frame of media is bigger than the rest of the frames. Not actually in frame size, but actually in bandwidth. And again, that will be rejected for that reason. So be careful of those details again and watch out for those. Audio is PCM audio. It's 24-bit. Now, obviously, potentially a lot of our acquisition sources are 20-bit. They seem to be quite happy that the audio is padded out to 24 bits. So that seems to be an acceptable standard. We've had no issues with that. But it must be a 24-bit stream that's delivered. So make sure your software can pad out 20 to 24-bit audio. Then the key is the space to add metadata. And we talked about that DPP shim. And one of the key elements that we've discovered with a lot of the MXF creation tools out there is that metadata shim needs to be at the head of the file. The reason it needs to be at the head of the file is what they want to do is they want to interface with that shim first before they start interfacing with the media. Because if they interface with the media and then they get the metadata, they go, that's the wrong program. They've wasted an awful lot of time. They can see that information right up front. As soon as that file comes in, they can start, okay, that's what we need. We know what to do it. Let's get the rest of the media and then move it on forward. So it's really important that it's at the head of the file. Again, if it's not, it's going to be rejected. So there's a lot of technicalities about that. So be careful again. Test it. Make sure you can do those things. To help support you, the DPP have worked with BBC R&D, and there is a free download application. They actually released version 1.1 yesterday. As always, there's still a little bit tweaking in the standard going on, and actually the metadata areas is what seems to be tweaked most of the time. But you can actually download this application and you can manually process that. And obviously we want to talk about automation as we go along. But you can actually manually enter that production metadata using the DPP shim. But as I say, we want to talk about automation. So we're going to talk about other applications that each really fit about that. And I'm going to take you to Content Agent in one moment. And we're going to go through that process now. So what I'm going to do, I'm going to switch you over to Content Agent. And here's our Content Agent. So first of all, I've got a source file. It happens to be an AVI in this scenario. So let's just talk about that metadata layer. So obviously one of the nice things we have on the fact is we have a layer of media management that tracks with all of our files inside Content Agent. So if I go into my metadata tab, obviously I've got all my factual metadata here. But as you can see here now, I've actually equally got my production metadata in the configuration for the DPP format. Okay, so I have now a metadata field group called DPP metadata, and then I have all the individual fields that are required according to the spec. So that makes my life very easy. So equally, I can come in here now and I can actually modify and manually enter that metadata. Or I can actually also import that metadata as XML. So if you gave me a file with some XML, I would automatically merge that metadata. And if your XML described your metadata as the DPP metadata schemas and gave me the individual fields, I can actually automatically interrogate that XML and bring that media into the system. Some clever stuff that we can do about transforming XMLs and bringing them to the system. We want automation on doing this. So you can see here now, I can now associate all the appropriate metadata that's for the DPP shim actually with the file. But obviously that exists only inside Content Agent at the moment in time. I now need to create that finished broadcast file. So what we're going to do is we're going to actually have a look at a broadcast deliverable workflow. So if I go into the system, and this is probably a typical workflow that I'm going to be using to do deliveries to my broadcast network. So first of all, let's actually analyze what's going on. So I've got my file, I've got my metadata that's actually associated with the file. So I've got my DPP shim details. First thing I've got to do is create the codec. So we've got here, I've got my Platinum transcode node, and let's have a quick look at that. So one of the things I really like here, first of all, I've got my ABC Intro 100. I just simply check that button, and I don't have to get involved with that codec anymore. Because we've got a standard, we actually conform exactly to that standard. We don't need to modify it or tweak it or do anything else. That's it. That is now giving me exactly the right spec for DPP for the ABC 100 codec, and we've obviously tested and played that back out. So you can see it's 1920 1080. Progressive in this mode. It could have been interlaced. And obviously you can see here my audio is a 24-bit audio. So we will automatically pad and convert and get the material into that format. So the great thing is we don't have to interact with that standard. My audio is set there at 24-bit, and equally I could be dealing with an international distribution where I may have multi-language channels. So maybe my source clip's got 24 audio tracks and I need to deliver 6 or 8 or whatever it is. So I can go through my 24 audio tracks coming in and I can patch and build templates according to the language channel that I need to deliver that broadcast spec out to. So you can see here I will do this and we will just select 7 and 8 in this scenario, and that's how we'll go out. The other element here, as you can see at the moment, I'm actually outporting that audio as mono tracks, and I'll talk to you about doing that. But let's just turn that back to stereo, and we'll say done. Great. What I will do, I'm just going to break this, because I always like breaking things. Audio options, I'll map this to mono. Done. So you can see there's my mono track. So one of the key things you need to understand here is no multiplexing has occurred. I'm dealing with separate video and audio files. And the reason why we're doing that is the multiplexer is actually going to be the MXF OP1A multiplexer. We're using the MXF to multiplex our signals. So when we create the MXF, that's the time we will actually multiplex all that media together. So let's just correct this again and put it to stereo. So audio options, stereo. Done. So there we stereo. And now what I'm going to do is I'm going to connect that up into my multiplexer. So if I'm very careful, and voila, there we go. So I've now mapped those all together. And what I've got here now is the DPP wrapper and multiplexer. So this is now going to create my MXF OP1A standard with the MXF OP1A multiplexer and insert my DPP shim into the right location. If I actually go to edit this template, there's very little to do it because it's an industry standard. I don't need to modify it. It just actually creates that file completely to that process. So we don't need to get involved in it. So we've now simplified and potentially automated the whole process of creating the file standard for a broadcast deliverable according to the DPP. So we've made that as easy as we possibly can at this moment in time. So we've now got our broadcast standard. What do we want to do with it? Well, we want to deliver it. But do we just want to deliver it from that stage? Well, the answer is pretty much likely to be no. We need to do QC. And we really need to think about what QC means to us. And now in a file-based automation mode, we've got some real advantages over QC that rather than the manual QC that we're used to. And this is a really great example of where we can introduce an external application that analyzes files for their technical specs. It opens itself up as a web service and allows us to integrate into that, share our data, and manage and continue our workflow with no other user interaction. So what we do here is we're going to introduce a product called VidChecker. So VidChecker is a separate running application. It happens to be running on this desktop. It could be running on a remote server. As long as I've got connection to it, I can actually manage it. So I could have a render farm of VidCheckers, I could have a render farm of transcode engines, but I could be managing that and automating the distribution of that material according to how I want. So if I take my VidChecker, you can see my web service interface allows me to scan the VidChecker, understand all the templates that are available to me that I want to assign to this workflow. Okay, and then also in this scenario, I've told it to stop the workflow until I get the report back from VidChecker, and I'll show you why in a minute. So let's just press done on that. And what we're just going to do, we're just going to jump to VidChecker and talk about that for a moment. So just use this. And here we are with VidChecker. So what the idea is, we have predefined templates about how we run. One of the nice things, VidChecker announced a new software release coming out very shortly, and they've actually put the complete DPP schema into their template. So you now have a template to do a full file-based QC analysis according to the DPP spec. So you don't even need to worry about setting up VidChecker. You just load the DPP spec template and you just run that automatically now. So that's really good. So if we look at templates, let's have a look at what VidChecker can do for us in QC. So I'm going to start a new template. So as you can see in my templates, one of the things we really like about it is just the simplicity of the interface. So I've really got 4 areas of check-ins. My structure of my file, my video, my technical video layers, and my audio check. So if we go to our file structure, you can see I can check that it's the correct MXF OP1A. I can make sure that adhering to the standards of pixel ratio, frame rate, etc. But I can actually go through and check each one of those. Does it have closed captions? File duration, maybe I'm expecting all my files coming in to be 30 minutes or 26 minutes, 30 seconds, whatever. But I can actually apply those elements and make sure what's going on with that scenario. If I go to my video checks mode, well, I'm managing my traditional video technical checks. So as you can see here, not only am I analyzing for my gamut, my video legal signal, so obviously my chroma levels, my black level, etc. Same things. I also have the ability not only to allow people to understand that there's a failure, I also have the ability to correct. So I've got a video legalizer built into the system. So what we can do in that scenario, if we say that the error is within 5% of the technical spec, then we'll probably say, go ahead and correct it. And this is where we really got to start thinking about file-based workflows in this scenario. We start modifying the core elements of the codec in the file. In this scenario, we're going to be modifying the video layer. We're going to be creating a whole new file, which means we have to transcode the whole file again. So we definitely have a limitation in file-based workflows, is that we have to re-encode the entire clip, not just do an insert edit as we would do in text. So we need to plan for that when we actually plan our timeline in our production timeline. So we have to do the thing. There is going to be technology, I expect really coming out next year, which will allow us to start doing insert edits. And that's going to be very interesting. However, even though we have to re-encode, the other efficiencies that we've gained in file-based workflows means we really should be building time into that area. It's just a case that we follow those disciplines. So what VidChecker will do is it will correct that file and it will deliver me an uncompressed file ready for me to re-encode in the system again. If we were running VidChecker as a standalone application, we could buy into their encoding system, which will actually encode in some of the limited broadcast applications. But typically we want our dedicated transcoding tool to manage that for us. So a couple of nice little things. So typically this is leading on with factual technical checks and not sort of production technical checks. But we do have the element to analyze if I've got an excessive duration of black frames, or maybe I've got an excessive freeze frame. You may have experienced it before. I've definitely seen it on TV. In that I've seen a program go out and then I had a section saying media offline in the middle of the broadcast. I do know on some reality TV programs, I won't say who, we actually changed the graphic on the media composer, so it didn't say media offline. It said British Telecom satellite down, and that went out with colour parts and said, just in case one of the operators forgot to link the media on. So if you've seen that, come and ask me later on. So you've got elements you can check on those things. One of the other elements we've got here is a quality perspective of the video pathway. So obviously with AVC Intra 100, that's a very high-end, high bandwidth codec, and we don't expect errors on those scenarios. There are scenarios where we can get errors, and those errors are, you'll hear typical MPEG slicing, etc. I don't expect to experience that with AVC Intra, but one of the errors we can do is we have an incredibly complex transitional scene. And I've had a couple of experiences, not many, but a couple, where basically there was this amazing animation as we transition from one screen to another. And what this animation did, it meant that every pixel on the screen was changing at every frame or every fill. And you can imagine that scenario is a very difficult, that's like random noise as far as the compression system. So what happened, the compression system really struggled and it created blockiness. So it looked very blocky through that transition. So again, we can actually analyze it and say, well, actually there's an error here, we need to have a look at. And we can choose and set blockiness thresholds on there. So we've got our video, we've equally got our audio elements, and again, not only can we test for duration of test tone, etc., but we can also look at peak, minimum levels, and loudness, which obviously has become a very big thing at the moment in time. Certainly throughout Europe, and certainly entering North America now, loudness is going to be penalised quite heavily by the various governments or states, etc. Again, with audio, I equally have the ability to correct that signal again. In that scenario, what I can do, rather than having to re-encode the entire clip, I can actually demultiplex my video and audio, correct my audio with my new path, and then re-multiplex them together again. That's a much more efficient way and speedy way of doing it. So if I am having loudness issues with my things, I can go ahead and correct them and then remap the audio back in again. So there are ways of actually speeding up that process rather than having to re-encode the entire clip, video and audio layers. So we've got that, we've got some general elements on the scenario, and I can just save that as a template and we can call that up later on into our workflow. So let's just jump back to Content Agent very quickly and just look at our workflow again. So as you can see, my VidCheck is there. I've called up my template. I've told the workflow to wait for the VidChecker to finish its job. When VidChecker has finished its job, it will report back to me saying, this is what I did. It will exchange its database and its metadata back into my metadata and my job management system. and then I will be able to analyze that job. So what I've done here in this scenario, I've got my file back, I've got my metadata back, and now I've got that Boolean-based decision node. So I can now analyze each of the field groups that's come back from VidChecker, and I can actually go, okay, did it pass or fail? I've done a very simple test here. Did it pass or fail? If it passed, well then I just go ahead and deliver it. I don't need to be involved in that clip. And this is where automation gets really good. I don't really need to be involved in those clips unless there's a problem. And I would hope, 80% of the media passing through me should be okay. Okay, so it's only that 10, 20% media that I actually actively have to get involved with. So that automation becomes very, very strong, but also gives me the confidence and security that my files are going out correctly. And that's what we need. We need that confidence going on with it. So we've got a couple of examples of delivery here. I've just done a network copy, and I could be doing a network copy to a server. I could be doing an upload to an FTP. And we're going to talk about some WAN accelerated software later on. At the same time, if I'm using the XML sidecar deliverables, I can deliver the clip, and I can actually extrapolate that DBP shim again, and actually deliver that as an XML stream, and actually deliver that as a separate XML layer to it as well. So what happens if it fails? Okay, well if it fails, then clearly I need to technically get involved with the file. So what I can do now is I can store the file off in my failed folder or wherever I feel that's appropriate. I can send an email, maybe I can send an XML script to my job management software to saying you need to alert someone about this. But I can create various ways of creating notifications that someone manually needs to get involved with that file. So when that happens, I actually give them all the details of the file, but even more interestingly, I actually give them a report. And you see on the VidChecker, I have the ability to output a HTML report. So I can actually give them a report with that system saying, you need to look at that file. So let's just jump across to VidChecker again. Okay, and if I go back to my task monitor, you can see here various reports that I've done. So here's a report here, and we actually had some errors in this clip, and what we did is we actually corrected them. So if I will get this link, I'll jump into that link, just scanning the report for me now. And as you can see, what VidChecker does, it actually gives me all the details of where it's made corrections or where it's discovered errors. It's given me the timecode, in and out point, a sample frame, and told me exactly what it's done. So I can actually go in there and say, okay, my threshold was 10 frames of black, and there's 12, but actually they're meant to be there. That was a design element, so I'll actually enable this file to go through the whole system. Or I can say, actually, it did a correction, but I want to see the correction first. If it's less than 5%, we probably just let the correction go through. If it was a correction that was at 30%, I think we really ought to look at that file. If we've got a 30% gamma error, there's something really wrong. But the beauty is the reports and all the information is there for me. So VidChecker we really like. We find it's really economical. It's very fast. It's rendering. It's opened up the cores on the computer that you're using to give you the best performance of the system. It handles multiple channels on a single computer. And we find the interface is very simple doing. I'm really pleased they've done this DPP schema. It's going to make our lives very much easier for broadcasters. And obviously the great thing is it's a web service, so we really keep all of our automation just flowing automatically through the system. So as I say, we've done that, we've analysed the file, and there it is. We now have a fully QC file, and we can now go and deliver that to the broadcaster with every confidence that's right. Or do we? So I keep mentioning the term technical metadata, technical or factual technical specification. And the key is we obviously can't analyze production errors, spelling mistakes. We can't obviously check for those. It's the wrong audio check. We can't check those. So there is still a need for visual QC, and we need to think about where does visual QC come into the equation. I think clearly if it's originally master files that were actually managed for redistribution, we would hope that actually just the automated process is going to work fine for us. If we've got a QC process in our post-production that enables us to actually work and check, do our QC in an environment that allows us to modify at timecode level rather than clip level, then that's actually a good place for doing a visual QC on those things. So that way we can allow automation. If we are producing new programs, then I think we still very much need to do a visual QC process. So there are several ways of doing a visual QC, and I'm just going to switch across to another product called Masterview. So one of the issues we've got to be very careful about with visual QC, I mentioned earlier when we talked about files, is I mentioned about gamma errors. We can also really struggle with computer displays. Computer displays are inherently progressive displays, and they can hide interlace issues. So we need to understand that. So really the best way we can have absolute assurance that our broadcast transmitted file is correct for gamma, is correct for interlacing, etc., is return that file to the finished viewing format. And this means we need to take it back to television language. So we're going to take it back to an SDI video. So what we have here is this amazing monitor against the screen. It's a program called MasterView. And what MasterView enables for us, it basically allows us to take our broadcast files, our MXF wrap files, whether they're to DPP spec or just standard OP1A. And what I can do is I can just open a file. Again. First thing what it does, it displays the metadata that's associated with that file. So if I had a DPP file here, it would give me all the DPP schema here. So I can actually just physically check that the metadata has been entered on the system. It obviously gives me a small waveform, etc. on the system. I'm not as worried about the technical information because I'm going to use my file-based system to do that. But I could, obviously do this as a PPMs or bar meter, etc., whichever way I want. But one of the most important factors does is it takes that MXF file and decodes it in Unity back out to an SDI video. So I can take this clip now, and as you can see, I've got my SDI monitor up here. If I just play on this clip now, I can actually do a full visual QC on a broadcast monitor that understands interlacing and recognize those interlace processes. So we don't want to take you away from visual QC. We still think it's very important. It's a case of that's another manual process, and we need to choose the right time of where that fits in. Cool. So we've now done our broadcast deliverables. We've QC'd them. We've done that. We're now ready to deliver our files. So how do we do that? And we've obviously got to start thinking about our internet deliverables. Let's just jump back here again. So what do we want to do? Well, when we start talking about internet deliverables, we're not just talking about delivering to our broadcaster. If we're going to have a strategy about moving media across the internet, we also want that strategy to map our incoming media. We want our shoot, to equally be able to deliver media to us. We want our remote scenarios to deliver media to us. And we also want to deliver media out to our publishing or our broadcasting environment. And there are lots of things we need to do now. We want it to be reliable. We pretty much want it to be encrypted. We don't want people picking up on the channel and pirating our media. We want to have receipt that the media has arrived correctly. So how do we do that? Do we do an FTP transfer? Pretty unlikely. And why wouldn't we want to do that? So let's have a look at FTP transfer. What we're doing now is we're having to consider the issue of latency. So what does latency mean? Basically, the further we get away electronically, the more amount of handshaking we've got to do for the system, which means it's a longer time for us to react. So if I just quickly go into command shell here. So here's our command shell here. And what we'll just do a quick ping on www.root6.com. So when we ping that, you see it's very slow to react. Probably lost my wireless connection. I've actually lost my wireless connection. But typically, I happen to know that service in the UK, and I'd expect a response time of 30-35 milliseconds. So it'll be a very fast response time, in which case my latency level is very low, and therefore I'm unlikely to drop packets. If I was going across to another server, then I'd expect that latency to expand upon the system. Let's just bring this back again. We'll carry on from here. So we'll carry on with what we've got here now. So let's actually look at that. So the problem is when we start dropping packets, what happens is we start degrading our bandwidth. Okay, so we suddenly, when we're into that 300 millisecond response time, our bandwidth is probably about 10-15% of its ability of what we can do. And we don't want that. We want our bandwidth to be the same no matter what the latency is in the system. So how can we achieve that? And the key is this packet drops. And this is where TCP/IP really fails us. So let's just try and look at an example of those different delivery mechanisms. So if I'm actually delivering a piece of media across to Dave here on the same network on here, I've got very low latency because electronically we're very, very close. And here's my packet data. I use TCP/IP, and that just transmits itself across in sequential orders, 1, 2, 3, 4, 5. It's very unlikely I'm going to have a packet drop out of that process. So that goes across smoothly. So in that low latency environment, we don't need any specialized software to actually improve what goes on. So now let's actually introduce latency into the system. So I'm going to take my packets of data again, and now let's do that with TCP/IP. So if we do that element again, so it starts delivering our data packets across. And obviously, when we're dealing with media, we're talking thousands, if not millions, of packets of data. So we come along, we dropped a packet of data. Number 4 arrives. It's not allowed to go in. The system says, hang on, I'm expecting in sequence. Resubmit again, start again. So 3 goes again, then 4 picks up, and then 5 picks up. So immediately on inherit and create delays. And as you can see, as more of those packets drops, the bigger delay, the lower the bandwidth you go. It really is as simple as that. So again, the intelligence of a WAN accelerated software like Aspera that we're going to talk about in a minute means what I do is I put intelligence at both ends of the network. And that means I can take over control of that and actually manage how my packets are going to be delivered. So now what happens now, I just simply start doing my deliverables. My packet number 3 comes along, it gets dropped. Packet number 4 comes along. And because I have intelligence this end, it just accepts it. Number 5 comes along and it says, okay, I've just got number 3 missing, can you bring that back to me? And it manages the ordering of that. So even on a very basic, low-level presentation there, on that timing, you can already start seeing the advantages of speed that go through that system. So that's what we want. We want a secure system that enables us the consistency and reliability of moving that packet of data that handles that drop frame element. So what WAN accelerated software does, it doesn't make my pipe bigger. The pipe is exactly the same. It makes it more efficient. So when I've got a 20 megabyte or 100 megabyte pipe, I will use all 100 megabytes. Whereas TCP/IP, my bandwidth of utilization of that pipe will degrade significantly over distance. And that's really the key to those elements. Again, because I've got intelligence at both ends, if I lose my connection, I can actually pick up from where I left and carry on transmitting, whereas TCP/IP, I have to start again. So one of the things we like with the system is we like to work with Aspera. And one of the reasons why we've chosen Aspera is we've got to think about how the simplicity of interface to make that intelligence work at both ends. Typically, when you start talking about this type of software, you tend to think, well, we need a server at both ends of the system. And there's intelligence in those servers, and we actually move data from one server to the remote server. So are we really going to do it that way? Are we going to have our own private servers everywhere? Are we going to connect to other people's servers? A, it's potentially expensive. B, it's cumbersome. And C, it's quite a technical element to set up. What Aspera brings to us is very different interfaces and how to go about that. I have an element called FastSpec, which means I can actually download the intelligence of the remote software through a browser. So someone can actually log into a browser, and very much in the way that you see when you log in your browser, there's a Java update or a Flash update for your browser, you're equally getting the Aspera update. It'll download the software in as the applet, and then you actually get the performance of that transfer across the system. They obviously have the Connect servers. You may have an animation company or someone you deal with on such a regular basis, then you might as well have a server at both ends. And also we're starting to see mobile applications. So Aspera supports Android and iOS, and I think they support BlackBerry as well. Allow us to use our mobile to transmit data. And that may sound crazy, but actually we're playing with 4G. We're seeing some phenomenal bandwidth with 4G at the moment. When 4G really starts to get taken up, I don't know how that bandwidth will reduce, but certainly at the moment I'm seeing 24 megabytes of transfer speed at the moment, which is incredible. One of the other nice things that Aspera have done quite recently is they've also introduced integration into Microsoft Outlook. That means I can email media across now. And what that means, clearly, IT and my Outlook Exchange server isn't going to allow you to email, your 400 megabyte file or whatever it is. So what happens with Aspera, it recognizes the size of that file, splits it away, and then uses the Aspera accelerator to deliver that file across to the other email address as a second layer on top of the Exchange process. So it's quite an interesting way and a very simple way to actually do deliveries through email. Well, we're really approaching the end of our day now. We probably ought to just show you a last layer of automation. And what we'll do is, I talked to you about that broadcast delivery, I talked to you about watch folders, etc. So one of the demonstrations of watch folders is to use QuickTime reference. So one of the things we wrote in very early days in interfacing with Avid and the setup is to deliver a QuickTime reference file. It's a very simple way of getting media outside of the Avid system. And what it means is what we're trying to do, that edit suite and the person operating the edit suite is a very expensive commodity. We don't want that person sitting around waiting for a transcode or delivery process to happen and render and costing you money to do that. So we need to get that media out of the system very, very quickly and automate the workflow process from doing it. One of the great things, formats with QuickTime is QuickTime reference, which is a pointer file. So what we can do is we're actually going to do a demo and show a QuickTime reference export out of Media Composer, automating and triggering a workflow, just to show you the reduction in time in your edit suite and allowing the professional systems that do transcoding to take over that element. So what I'll do, I'll just come out of here for the moment. And what I've set up here is a watch folder. So we can have up to 64,000 watch folders, each with different workflows assigned to it. So remember I mentioned that issue of one, we don't really have that issue. So here's my watch folder. You see I'm actually watching a folder on X, which happens to be on my ISIS setup, and I'm actually just going to do a quick iPhone situation. Let me just pass you to Dave again, and he's going to now trigger off a QuickTime reference export.
So we're back in Media Composer, and this could be a quick viewing copy for the director who's about to jump on a train. So find the sequence, right-click, select Export, and then we're just using a very basic QuickTime reference into the watch folder. And as you can see, very quick, exports the tracks, and then I can carry on editing, you know.
Great, so the edit suite's been released. If I jump to Content Agent back here, so obviously that folder's there. I'm scanning that folder. I've just seen activity, so no hands. I hope you saw that. And then my job's been picked up, and I'm now managing that process. So I could have been managing that process on my broadcast delivery, and the end stage of that broadcast delivery, if it's passed all its QC, is I could put it into my Aspera server, and it will automatically do that delivery for me. So I can automate everything from that QuickTime reference right through to actually the finished file arriving at the broadcaster with no other interaction. And this is really the power of file-based workflows, that automation process, and the fact we can get those materials out of our very costly suites and into the machine room, into our racks and our servers and do that. So we pretty much have concluded everything we want to go through today. We've taken you through the file-based workflow right from the original video or file-based ingest through into post-production. We've managed the asset, we've tiered our storage, we've made our storage cost-effective, we've edited, we've distributed to different software applications, we've re-encoded it ready for broadcast levels, we've QC'd it, and now we've delivered to a WAN accelerator server with Aspera and actually delivered to the broadcaster. And that concludes. And funny enough, it's exactly 1:30. So